With these videos, I want to explore some of the latest test automation tools and how they can be used in real-world testing scenarios. This is not intended as a tutorial, but more an overview of practical application and how the tools integrate with cloud environments and how they fit into modern CI/CD pipelines. We're going to start with Playwright, a powerful framework for browser automation, and using it to test a real-world service on the government UK website. So let's break down what we'll be covering in this video. So first we're going to introduce Playwright and why it's a great tool for modern web testing. Then we're going to look at the application under test, in this case the UK government's reporting system for linking into local council websites, and we'll analyse the user journey and decide what we can automate. We'll write our first Playwright test, running it in headed mode so we can watch it interact with the website. After that, we'll move to headless execution so we can optimize for speed and CI/CD use cases. Once we have a working test, we'll make it data-driven, allowing us to test multiple postcodes dynamically. We'll further improve the structure by moving our test data into an external JSON file for better maintainability and scalability. With our automation now scalable, we'll push the code to GitHub, setting up a repo for further integration. From there, we'll build a CI/CD pipeline in AWS CodeBuild, and we'll automate our Playwright tests to run in the cloud. Finally, we'll set up webhooks, ensuring tests are triggered automatically every time we push new changes. By the end of the video, we'll have a complete end-to-end automation setup from local test execution to cloud-based continuous testing. So let's look at the first of those, which are the features of Playwright and why we might choose Playwright as our testing tool. Well, it's strong at cross-browser testing. It'll support Chrome and Firefox and also WebKit for Safari type browsers. It's good at mobile testing. It'll emulate real mobile devices and it'll run on Android via Google Chrome for Android. It's easy to switch between headed and headless modes, and it will also support parallel testing with more than one worker. It's good at automated user interactions, and it's quick to script those user interactions. It will also support network interception and request mapping when you need to do API mocking and testing. So let's now introduce the application under test. I want to look at real-world applications and how we might use tools such as Playwright to perform the testing. So we're on the UK government website and we're in the section for housing and local services. If we scroll down on this page, we'll see a number of sections, but the one I'm interested in is streets, roads, pavements and buildings. If we select that option, then we're directed to more options within this section, and we can scroll down and we can report problems on the roads. Now, any UK driver will be well aware of issues we have in this country with potholes, so let's select that one. This then gives us a page that is designed to send us to the correct local council website based on the postcode we enter for where the pothole is located. So what we can do then with Playwright is test that entering a postcode is indeed sending us to the correct local council. So let's start by entering this postcode, SW1A1AA, which I believe is the postcode for Buckingham Palace in central London. So you can see that it's matched us with the city of Westminster, and it's updated the button on the page with the text "Go to the City of Westminster" website. So if we click that button, it should then direct us to the local council website in the area where we've seen the road problem. And you'll see now that it's actually taken us to the City of Westminster site, and it's dropped us onto the page titled "Report a Road Damage Issue." Then if we go back to the national site, we can then ensure that if we enter another postcode, in this case a central Buckingham postcode, then we should see that we are directed to the Buckinghamshire Council website. And if we then click on that button, we are directed to the correct website, and we're on a page entitled "Report Problems on Roads, Streets and Pavements." We're now looking at that test in script form, written in JavaScript. You can see two windows on screen. On the left is a PowerShell Windows terminal, and on the right is a simple notepad editor. I don't want to go into the install process, but Playwright has been installed locally, and I've set up a Playwright project directory. Within that directory there is a config JavaScript which describes a minimal configuration setup for this test. You can see that it turns the headless mode off, so we can see the browser as the test is executed, and there's a slow-mo parameter introduced to try and slow the execution. There is a screen position parameter set to a negative value. This is to place the browser on the window here, as I'm running a multiple monitor setup, but I'm only recording the one screen, so that negative value is simply to place the browser within the recording. And then finally in the configuration there's a default location where the tests are stored. If we navigate to that directory, you can see that the only test in there is the pothole JavaScript that we just briefly looked at. So let's quickly review that script. It's quite bloated because there's quite a bit of console logging and waiting added in there, just so it's more visual, so we can actually see things. We can see the logging going into the terminal, and obviously when the browser's running we're waiting so we can actually see the controls as they're executed. So step one is navigating to that government website, and we're actually hard coding that URL. It's then conditionally accepting cookies, so that's just for the cookie pop-up, just so we're controlling and interacting with that. And then the next steps are simple click events, navigating through the pages that we've already looked at until we get to that text box where we can enter the postcode. Then we're using the page fill command just to enter the data, the hard-coded postcode data. And at each step we're expecting the text or controls to become available so that we're then in the right place to execute the next step in the process. After we navigate to the Westminster Council website, we're expecting that URL to contain the westminstergov.uk, and just so we can check that we're redirected to the correct place. And then once we're on that page, we're actually looking for that text, report a road damage issue, which is an indicator that we've landed on the correct page on the Westminster site. So let's briefly discuss the elements that we've used in this script and how it's been built up. So what I'm doing is manually on a browser window, I'm looking at that website and simply right clicking on each control I want to interact with and doing inspect within the browser. So then that will take me into developer tools, and I'm then able to look and copy those elements or look for the best identifier to specify that control on the page, the control I want to interact with, be it a link or a text box. I'm specifically looking for identifiers that are persistent and unlikely to change. This is for the purpose of adding to the robustness of the script, so wherever possible, looking for identifiers such as name or control ID, and you can see throughout the script I'm actually using name as the identifier. So let's now call out to the Playwright runner to trigger this script. I'm not telling it which script to run, as there is only one test in the test folder, so it'll just execute that one, which is our pothole script. And then we will see it run through in headed mode, so it's bringing up the browser window, and then it's stepping through each step on screen. You will see that even though I'm slowing it down considerably, the execution of the basic script is still relatively quick, and Playwright is identifying that the script is running slow, but that is because we forced it to be slow, and without all these waits it would just flicker on the screen and we wouldn't actually see it working at all. So what can we do to improve this script? Well, one thing would be to take the hard-coded data out of the test and put it into its own section for clarity and easier maintenance. So I've introduced a test data constant, and I've assigned my hard-coded data to individual parameters. Then the script is then referencing these parameters rather than the data itself. So if we run this now in headless mode, we'll see that it writes out the logging to the console, but this time it's not showing the browser. And you can see without the added weights and without the browser window, it's completing much faster. What can we do to further improve and make the test useful and more reusable? Well, we can externalize the test data entirely. So that test data, I can take it out and I can put it into a JSON file like this one. And you can see here that I've now also doubled up the test data, so we've got two scenarios. Obviously I could put more and more in this JSON file to run the test against lots of different councils. But as we're running the first test against the Westminster Council site, and then we're running a second set of test data directed to the Buckinghamshire Council site. The driver script itself is much the same, but it's now referencing the external JSON file instead of having the internal data. And if we execute this script, we'll now, in its new form, we'll now see that it does something slightly different. It reports that it's running two tests with one worker, and you can see that it's now reporting back which postcode is entered and that it is successfully asserting against the expected council site. So we saw the test successfully run with two lots of test data. It's doing something a bit more useful now. It's testing two council websites, and we can see that we could quite easily expand that out to many more. But at the moment, this code is sitting on my hard drive on my Windows machine, and we need to start looking at how we can further expand out, give us some source control, and then how we can move into getting the code into the cloud and how we can integrate with CI/CD. So the first point to do that is to create a repo in GitHub. So that's what I'm doing here. Just gone into GitHub, and I'm just going to create a new repository and use the default settings to get a repo up and ready. Once the repository is created, we need to set up Git to tell it the address of that repository. We need to create a branch, so let's use main for now. Then we need to push the code to the origin we've just created on the main branch. And to do that, I just need to enter my GitHub credentials. So there were a couple of issues with what I just did. I initialized at the wrong level locally, so it was staging the whole of the high level folder instead of specifically the Playwright project. So I've had to initialize again at a lower level to stage the correct files. I've also now added this git ignore file, so it will ignore some of the files in my local directory to control what we're actually pushing up to GitHub, because some of these files I don't actually need in GitHub. Git status will give us what files are currently unstaged, and that looks better. We have the config file here and the test folder containing our potholes test script. So let's switch to our main branch. We should then be able to add everything that is currently unstaged. So I need to commit those changes so they're then staged, ready to push. That looks good. So now it's a matter of pushing the origin main branch. Okay, so that's happening because when I reinitialized, it didn't reset the origin, so I need to do that again. And then I need to push again and enter credentials. Okay, the joys of Git. So this one is because we've got a discrepancy between what's in the repo and what I have locally. The error is actually pretty clear, actually. So the issue is actually the README file. So the README's up in the repo, but it's not local. So to fix that, I first need to do a pull. So that brings me the README file. Just need to recommit. Okay, nothing to commit, just check the status. Clean tree. Okay, so we should just now need to do the push. Enter credentials again. That is looking more promising. So now we just need to go back to GitHub and check the repository. And we can see that all our Playwright project files are now uploaded to our repo. We're on the final two sections now, so we've got to move on to AWS CodeBuild now and just getting the Playwright tests running in AWS, and then we can look at more of the integration with GitHub and how we can get automated test execution running up in the cloud. We're in AWS and specifically AWS CodeBuild now. So this is a fully managed CI service for compiling source code and running tests and producing the ready to deploy CD side of things as well. So it's a CI/CD pipeline. We're going to create a new project, and then first off we're going to link into the GitHub repo we just created. And to do that, I just need to specify a new connection and then tell AWS how to link into that Playwright repository we just created. Back in CodeBuild now, the project has the GitHub connection we just specified. We've got a role specified, but we're missing a build spec template. So this template will tell AWS how to interact with Playwright, how to install it, and how to run the tests. It basically contains what we've just used on Windows Terminal, but obviously within the file. So I need to save this template locally and then push it up to the repository as well, so it's then within our repo and accessible to AWS, and that means it's within our source control as well. So I saved that build spec template locally, and then I pushed it up to the root level on the repo. So we should see now that within AWS I can link into it, and that should be the last part of what I need to actually create the build project. So let's create that. I've manually tested the build now by triggering it in the AWS environment, and we can see that we're failing here on a dependency, so it's not installing Playwright in the AWS environment, and it's given me a package manager error. So I just need to investigate why that's failing. So I found the package.json file is as it should be in the local directory, but when I tried to stage again and push it to the repo, I realized that the issue is that the gitignore file is set to ignore it. So that's why it's not going up into the repo, and then why AWS is failing on the build. So I need to make a change to the git ignore so I can get that file pushed up. I made the change to the git ignore, so I got the package.json file into GitHub. And I've now rerun the build in AWS, but as you can see, we're hitting another error. So this one relates to the AWS environment that we've chosen or not chosen, because it's defaulted to Alpine environment, and Playwright is failing because it's not compatible. Playwright install was going to need an Ubuntu or a Debian server build. So if I go back into the build and edit it, and here if I then modify this to use an Ubuntu image, and then we should be in a position to retry the build. The build has actually gone through now with the Ubuntu image we specified, but the Playwright tests are failing now, as we can see here. So I'm keeping all these issues in the video as I think it's useful to trace through the problems. This problem is because I forgot to change the Playwright config and left the headless switch set to false. So in the cloud build, it's trying to run a browser, which it can't do unless there's a virtual display server, which there isn't, as we didn't install one via the build spec template. So the remedy for this error is to change the Playwright config, which we should have done to start with, and switch that headless mode to true. And then we need to re-push that config to GitHub and try the build process again. Switching the headless mode off has done the trick, so we now have a successful build on AWS. All the logging is coming through, and further down we can see our familiar test output. So the Playwright tests are now running and they're reporting success. We can see that the London postcode is going through here, and then further down we can also see the test using the Buckingham postcode. We can also see that Playwright has optimized the tests and is now running 2 workers. But this has created a mixed up log output as the 2 tests are now writing to console simultaneously. Don't want to worry too much about this here. There would actually be a number of solutions to this, ranging from forcing Playwright to go back to serialized output to changing the way we're reporting and changing the output. In a real world scenario, we would obviously need to fix that. However, I'm more interested for this video in moving on to continuous integration and moving on to automated builds based on an event. So to do that, we need to now look at webhooks. So let's pick that up next. AWS makes this quite easy. In our build project, there is a webhook section, and we just need to tell it the event that will trigger the rebuild. So I want to build when I push new code to the repo, and then depending on how we authorized AWS with GitHub, it should propagate that webhook back into the repository. So back in GitHub, we just need to check that within settings, webhooks, just to ensure we've got the webhook in the repo as well. Let's now demonstrate this working. First, we need to make a change to our source code. Just a change to a comment will do. If I then save that and do a git status, that will report there's a modified file. So I need to add that file so its stage is ready for the commit. do the commit. And then I just need to push that up to the repo. We can now see that there is a rebuild in progress. So whilst it does that, let's summarize what we've done. So this is demonstrating continuous integration. So this is the CI part of what you hear a lot of, CI/CD. So a developer has pushed a code change to GitHub, and that has automatically triggered the build using the webhooks. And AWS CodeBuild has therefore started on its own, and as part of that build process, it's fetching the latest code from the repo. As it's built and as it's gone through, it's then gone to the Playwright tests, and they've executed as part of the build. And in a real world scenario, this would work to ensure that a code change is functional and the code change that the developer has made hasn't broken the application, and our tests are running through to verify that. We're then reporting back the results of the tests. We're doing that within AWS CodeBuild logs, but that could also be some more formal reporting. It could be in GitHub, or it could be some form of notification, such as an email. And then that automated cycle of code validation can be used to ensure that every code change is tested without manual test intervention. And that could then be used to move forward to code pipelines and to the CD side of things. But I don't want to go too much further with this demonstration. Quite happy to finish there with the demonstration of continuous integration.